This is Mr. Griffith, and again we are in Chapter 2.1, Sets and Whole Numbers. And we have already taken a look at the idea of subsets and proper subsets, and looked at some of the ideas of notation. To expand the idea further, we're going to talk about the universal set, the empty set, and the complement of a set, and then delve into the idea of what whole numbers actually are, and begin looking at some operations. And so when we want to talk about a universal set, we're going to say that the universal set is the set of all elements under consideration. Okay. Now, this idea of all elements under consideration, when we're not just talking about the set of everything, okay? Although we could, I suppose. But a universal set occurs in very much a particular context, okay? So when I write a word in English, I do not write it like this. Okay, that's not a word that you would see in English, okay? Now, why not? Okay, these symbols have no relationship to the symbols that are used in the English alphabet, okay? They, in fact, are just scribbles, okay? So, when you see a word in English, it's only going to have English letters, the English alphabet. And as a result, we can say that the universal set of characters for writing English words is found as the English alphabet. And so I could write a set and call it U for the universal set, and call it A, B, C, D, and continue on with this ellipsis that describes going on as indicated until we get up to Z, the last letter in the English alphabet. And what would this mean? Well, this would mean that T is an element of set U, okay? But 3 is not an element of the universal set. Now, this is going to have some consequences, okay? We know that T is a letter in the English alphabet, but 3 is not a letter in the English alphabet. If something is going to be contained in the universal set, then it exists as an element, okay? On the other hand, if it is not found in the universal set, then it does not exist as an element, because the universal set is the set of all elements under consideration. And so you can see that I can have this universal set of all the letters in the alphabet, and 3 is not a letter because it is not contained in there. Well, let's try a somewhat smaller universal set so that we can look at this. And so let's just let our universal set be 1, 2, 3, 4, 5, 6, 7, and 8. The first 8 counting numbers, okay? And so if you take a look at this idea right here, I can construct another set from it, okay? So if I want to construct set A as being 1, 2, 3, 4, and 5. This is fine. Every element comes from here. And in fact, we know that A is a subset of the universal set. Every set is going to be a subset of the universal set. And, but what if I had something like this? What if I had set B as being 1, 2, and 9? Well, actually, because 9 is not in the universal set, okay, then something happens. B is just simply the set 1 and 2. Why? 9 is not an element of the universal set. What that means is that 9 does not exist as an element. Well, now, the universal set is the set of all elements under consideration. And so we have a set of all elements. So let's consider what a set of no elements would look like. Can we have sets with no elements in them? Oh, I think so. Okay. I was asking my students the other day how many children they had. And one student had 4 children. Another student had 1 child. And several other students had no children. And so I said, well, does this person with 4 children, does she have a set of children? The rest of the students agreed, okay? And then I asked about the student who had 1 child. I said, does this student have a set of children? There was some disagreement. Someone said, well, no, doesn't a set have to be 2 or more items or 3 or more items? I said, mm-hmm. She has a set of children. She happens to have 1 person in that set. Okay. And then I took a look at a student who didn't have any kids. And I said, and let's talk about your set of children, young lady. And she looked up at me with sort of eyes got real big. And she said, I don't have any children. I said, that's fine. I said, your set of children is empty. You have no children, so there is no one in that set. And she looked a little relieved and she said, I said, the fact is that we don't have to have anything in a set for there to be a set. A set is a container. Can you see that? A set is a container. In the universal sets idea, it is a container that holds it all, right? Okay. And in the empty sets notation, it is a container that holds nothing. Okay. A is a set. It contains whatever elements that it contains. Okay. In very many ways, sets and variables are pretty close to being identical types of structures. Well, there's a few differences. But the idea is that a set is a container. It holds things. All right? And so we're going to find out more what to do. The empty set has no elements. So we're going to say that the empty set is the set of no elements. Now, this sort of begs the question, okay? Here we have this universal set which contains everything. Here's this empty set which contains nothing. And here's every other kind of set which contains something, just not nothing, okay? And so we want to talk about how these things are related. And so when we look at this, we have an idea of inclusion and exclusion. In fact, the two big ideas for sets, two big ideas, are inclusion and exclusion. What we keep and what we throw away, what we have and what we don't, what's on my team and what's not on my team, the medicines I take, the medicines I don't take. Ladies, so you get up in the morning and you look at your jewelry box, what earrings will you choose to wear and what earrings will you not choose to wear. Or you go to a pizza parlor and you look at the list of ingredients that are available and you choose some ingredients to have on your pizza and you reject the rest of them from being on the pizza. This idea of inclusion and exclusion. And every time you include something, you exclude others. For example, here in A, I have included 1, 2, 3, 4, and 5. Well, what didn't I include in A? Well, in this case, I did not include in A 6, 7, and 8, okay? And this idea of exclusion here, we are going to call the complement of the set. Now, the complement of a set, if you see this root word right here, this root word comes from what we now see as complete. And a complement is that set of elements that would complete set A. This set would make A to be the complete set, that is the universal set. The universal set is the only set that is a complete set, okay? And so, here's this idea of a complement. And so let me ask you, what would complement the empty set? So let's see, the complement of the empty set would be that set of elements that would complete the empty set. And so it would have to be, well, let's see, 4, 5, 6, 7, and 8. Oh, well, it has to be the whole universal set. The only thing that can complete the empty set is everything, getting everything. And that's the universal set. On the other hand, if I ask, well, what elements are needed to complete the universal set? Well, let's see. Oh, well, I don't need anything to complete the universal set. So in that case, what completes the universal set is set of no elements, and that is our empty set. You can see that in this situation, all right, this idea of inclusion and exclusion, whenever I create a set that includes certain things, I am creating another set that excludes the rest. And so we have quite a nice little set of things. So, in this idea, then, what I'd like us to do is I would like us to think about subsets and creation of subsets. And in doing this, let's start with a set A. And let's talk about set A as being 1, 2, 3, 4, and 5. Now we're going to create all the subsets from set A. And here's how we're going to do it. Well, first of all, I'm going to take no elements from this set. Now this is going to work, okay? This is going to work for us because you remember that essentially a subset is a set whose elements have been, taken from this, And in fact, I've been able to construct the empty set from set A simply by taking no elements. Okay. Now, I'm going to also, at this point, write down the complement of the set. Because the complement of this set with regard to set A, okay, is going to be 1, 2, 3, 4, and 5. This is a complement. Well, actually, this is not a complement. This is the complement of that empty set. You can see that right there. Okay. And so now, let's start off with things like set containing 1. Well, you can see that I would have 2, 3, 4, and 5 that would complete that to create this set A, right? And if I had 2, I would have 1, 3, 4, and 5. And if I chose 3, I would have 1, 2, 4, and 5. And if I chose 4, I would have 1, 2, 3, and 5. And if I chose 5, I would have 1, 2, 3, and 4. Now you can see that all of these are subsets there, right? Okay. Well, now what about subsets of size 2? Well, I can do that. I can do this as a subset of size 2, this one, 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 and this one. Okay, so let's see what I can do here. I'll start here, so let's see. Well, here's 1 and 2, and then I can write 3, 4, and 5, and then I can have 1 and 3, so I would have 2, 4, and 5, and then I would have 1 and 4, 2, 3, and 5, and then I would have 1 and 5, that's 2, 3, and 4. No, okay, so 2 and 3 would give me 1, 4, and 5. Let's go over here and let's see, that would be 2 and 4. And you can see that I would have 1, 3, and 5. Okay, and then I could do 2 and 5, which would give me 1, 3, and 4. And then I could have 3 and 4, which would give me 1, 2, and 5. And then I could have 3 and 5, which would give me 1, 2, and 4 as the complement, and 4 and 5, and 1, 2, and 3 as the complement. Now what I want you to do is I want you to see what's happened here. Okay? I have all these subsets here. Let's see how many I've got. 5, 10, 15, 20, 25, 30, 31, 32. I have 32 subsets. And later on we'll see if that's how many we actually ought to have had. Okay. I have subsets of size 0 right here. I have subsets of size 1 here. Subsets of size 2 there. Subsets of size 3 there. Subsets of size 4 here, and a subset of size 5 there. Okay. Now, take a look at this. Do you see that for every set I started writing, it had a complement that I could write, and I could write not only what I took, but what was not what I had taken. Okay, so every set can have created has a complement, which is also created by it. We, in fact, were able to create all the subsets of this rather significantly sized set fairly quickly and easily doing it this way.